Hello everyone and welcome back. So in our last lecture we see what is inverse Laplace transformation, some standard results and the theorems. So in this particular lecture we are going to use those standard results and theorems to do some applications or examples. So problems are very simple. Suppose find the Laplace transformation of this particular example. You see s minus 2 s plus 5 and then 6 divided by s to the power 4. So by using linear property, first you have to separate them. Then next one will be, here you can write 2 outside, 1 by s plus 5, here 6 outside, L inverse of 1 by s to the power 4. Now think which property we are going to use here. So there is one property like Laplace transformation of 1 by s minus n. So I think you remember now, it's how much? E to the power at. And then the next property is 1 by s to the power n plus 1. This is how much? T to the power n by n factorial. So these two property we are going to use here. So this is very simple. E to the power, just write 2t. Then 2 into, here plus is there, no, so it will be e to the power minus 5t, then 6 into, see, this is 4, so 4 can be treated like this 3 plus 1. I'm talking about this particular formula, n plus 1. So 4 can be treated like s to the power 3 plus 1. So here n is 3, so how much it is? T to the power 3 by 3 factorial. 3 factorial is 6, so this will cancel out. So e to the power 2t, 2e to the power minus 5t, and then how much it is? T cube. Okay, so it's very simple, you see. Okay, so next let us take one more problem. So we see first shifting property. So in first shifting property, what we see is L inverse of f of s minus a is equals to what? E to the power at f of t. So this particular property, using this particular property, now we use or we will do example number 2. So here we are asked to find L inverse of s minus 2 and then s minus 2 whole square plus 5 square. Okay, let us write it together first. Then s plus 4 divided by s plus 4 whole square plus 9 cube. Okay, plus 1 divided by s plus 2 whole square plus 3 square. Okay, 3 square. So these are the three different terms inside the Laplace transformation. So what we'll do, first we'll separate this by using linear property. S minus 2 whole square plus 5 square, the n inverse of s plus 4 divided by s plus 4 whole square plus 9 cube, and then L inverse of 1 by s plus 2 whole square plus 3 square. Okay. So before starting the solution, I'll do one simplification from this particular property that you just try to understand. What we see L inverse of f of s, right? L inverse of f of s is sorry, 1 minute. Okay, so for the problem this is not necessary, but how we use this particular result, that you have to understand. We know that L inverse of f of s minus a is equals to what? E to the power at f of t. So I'm talking about first shifting property. Now if I replace s by s plus a, then what will happen? In place of s, I'm going to write s plus a. So then minus a is still there. So now what is our right hand side? E to the power at, then it will be f of t. Okay, also we can write like this also. See, e to the power at, what is f of t? F of t is what? L inverse of s, small s, right? L inverse of small s. Then this will be your L inverse of, in place of s, what we are replacing here? In place of s, we are writing s plus a, right? So this implies L inverse of, here a cancel out, L inverse of f of s is equals to e to the power at, L inverse of what? This is our f of s plus a, f of what? S plus a. So this is just a simple modification of what? First shifting property. So see, in first shifting property, in the left hand side we have f of s minus a, but suppose in some problem we have what? F of s plus a, sorry, f of s, then the formula will look like this. And if it is like this, e to the power at, L inverse of f of, in place of s plus a, suppose it is s minus a, then what will be the left hand side now? Then this term will be your minus then. Okay, this term will be negative and left side is what? Same. So if it is plus a, then it is s plus a. If it is minus a, then you have to write f of s minus a. So these two rule you just have to remember for doing this particular problem. Okay, now just observe this particular part. This is this one, L inverse of f of s, but see here s is how much? Here s is our s minus 2. Okay, s is s minus 2. So what is the right hand side then? If it is s, then right side is either s plus a or what? S minus a. So since it is minus, what we have to write? For minus we have to write plus. So now see what we are going to write. E to the power, if it is minus, then e to the power at, first formula we have to write. So e to the power, I am going to write 2t. I am writing this term. So what is then inside we will get L inverse of, now it is how much? Now it is s plus a. S plus a means our a is what? 2. So in place of s, see, in place of s, if you write s plus 2, so plus 2 and minus 2 will cancel out, you will get simply s, and then denominator, in place of s, if you write s plus 2, you will get s square plus how much? 5 square. Just try to understand this part. Or you can remember like this also, since both the terms are similar, s minus 2, s minus 2. So if you write e to the power twice t, then both will reduce to s. Like this also you can remember, but the actual thing is by using this particular rule it will come. Okay. So if it is minus, then this formula e to the power at, and here you see plus. If it is plus, then you have to write e to the power minus 80. So let me write it. See, now we have s plus 4. So here a is how much? A is minus a. So it will be e to the power minus 40. So whenever you write e to the power minus 80, our s will be s minus a. That means in place of s, now we are going to write s minus 4. S minus 4, then plus 4 cancel. You have only s, and then here you have s square plus what? 9 cube. Okay, is it all right? And then let me say what we'll going to write here. It is plus now. If it is plus, then minus 2t L inverse of what? 1 divided by s square plus 3 square. Okay, is it clear? So it's very simple. Just you have to remember this particular part. Now it is very easy. E to the power 2t. So which formula we are going to use here? S divided by s square plus s square is nothing but cos 5t. Then e to the power minus 4t, L inverse of how much it is? S divided by, so this is 9, it should be square, huh? It is not cube, there is one printing mistake. Square, this is square. So again it is see s divided by s square plus 9 square, so it will be cos 9t. And then e to the power minus 2t, last one is what? It's a 1 is there, no? So it is sine at by a, sine 3t by 3. Okay, so the problems are very, very simple, but you have to understand that which formula we are going to use. Okay, let us take one more problem. Suppose we have to find the Laplace transformation of 1 divided by s minus 4 whole to the power 5, then 5 divided by s minus 2 whole square plus 5 square, and then so whenever you practice some more problem, no, then all the doubts whatever comes to your mind, it will be clear. So you have to practice some more problems. So first let us write them separately. It's 5, then 5 is constant, L inverse 1 divided by s minus 2 whole square, then 5 square, and then finally L inverse s plus 3 divided by s plus 3 whole square, then what, 6 square. So here you see what is a, it is plus 4. So we are going to write e to the power 4t. Okay, so then it will become 1 divided by, this will vanish, in place of s we have to write s plus 4, 4 cancel, you will get s to the power 5. Then here for this term you have to write e to the power 2t, then this will reduce to 1 divided by, now it will be s square plus 5 square, and for this here it is plus, no, so minus 3t L inverse, so in place of s we are going to put s minus 3 cancel out, so this is our s divided by s square plus 6 square, right? Now we have to use standard result, so it is, this is of the form 1 by s to the power n plus 1. So what is our n plus 1 here? This 5 is 4 plus 1, so you can write t to the power 4 by 4 factorial e to the power twice t, so this will be our sine 5t by 5, then e to the power minus 3t, this is nothing but cos 6t. See how many lines, 1 2 3, within 3 lines you will get the answer. So that's why the problems are very, very simple, okay, provided you have to practice it. Okay, so let us take one more problem. So let us find L inverse of 1 divided by s minus 3 and then s plus 4. So this one we have to simplify it because there is no rule like this, no, this into type, there is no formula. So let us simplify this a little bit. Can we write s plus 4 minus s minus 3 in the numerator? In the numerator actually we have 1. But whatever I am writing now, you see s cancel out. So it's 4, or better you can give it plus sign. See 4 minus 3. 4 minus 3 is how much? Exactly 1. So in place of 1, if you write these two factors, so after simplification, you will get 1 only. And then denominator s minus 3 and then what? S plus 4. Now what is the benefit of this balancing? Otherwise you have to do partial fraction. So it's very simple. Within one line you can balance it. Now if you divide it, you see when you divide this, s plus 4 cancel out, so you'll get s minus 3, and for the second one, now s minus 3 will be cancelled out, you will get s plus 4. So now standard result, e to the power, this is e to the power 3t and this is e to the power what? Minus 4t. Finish. Okay, so let us take one more problem so that you can understand it better. One similar type of problem let us take. L inverse of 1 divided by s plus 1 and then s minus 2. So L inverse of, now here what we can write? We can write s plus 1 minus s minus 2. Now see after simplification it will not be 1. So s cancel out, but it is 1 minus plus 2, so 3. But actually you have 1, but here after simplification, or if you give plus sign also, no, if you give plus then still there is minus 1, so it is not coming. So let it be minus, so 3 is an extra term. So what we'll do, we have to balance this 3 outside, 1 by 3, then it's same, s plus 1 and then what? S minus 2. Now when you split this, 1 will be our L inverse of this cancel out, 1 by s minus 2, and then another one is L inverse of 1 by s plus 1. So the formula, after using the formula, first one is e to the power twice t, next one is e to the power minus t. So this is the answer. Now whenever you see all the problems, you see all the problems are very, very simple. Okay, so let us take one more problem. L inverse of s plus 2, and then s square minus twice s plus 5. Now if you look at the other previous problem, so if you see that if it is s plus 2, no, then here also we must have one s plus what 2. So then only we can use that particular first shifting property. So let us see what we can write here. S square minus twice s plus 1, and then plus 4. Okay, can you write like this? Same 5 we are splitting in 2 part, 1 plus 4, and this is what s plus 2. Then L inverse of, now see this part is nothing but s minus 1 whole square plus what 4, but here we have s plus 2. So let us write like this, s minus 1 plus 3. Okay, now it's similar type s minus 1, s minus 1. So what we have to write, e to the power t, then L inverse of, in place of s we are going to put s plus 1, 1 1 cancel out. So what you will have now, s plus 3 divided by, you have s square minus 4. Okay, so e to the power t, then we have to split this. One will be your L inverse s divided by s square plus 4 is our 2 square, and then take 3 outside, L inverse of 1 divided by s square plus 2 square. Okay, so e to the power t, so its simple formula is cos twice t, and then it is how much, sin twice t. Okay, so I'll include some more problems on this inverse Laplace transformation, but in the next video, but otherwise this video will be a bit lengthy. So kindly practice some more problems of similar kind, so that the applications of inverse Laplace transformation will be very much easy for all of you. So thank you for watching. Kindly like and share with your friends.